All right, that's better. Afternoon, students.
Good afternoon, sir.
All right. So we're still on the statistics. And what we want to do now is just to practice and practice and practice. So I don't think I'm going to give any classwork today as yet. What I'm going to do, I'm going to let us practice some questions. Give you the opportunity to redo those questions. And then on Sunday, we can do the classwork on Sunday. All right. So I think that's a plan. So we're going to do some past papers, some June past papers. I know there are some questions in the handout that I gave you, but you know, since we have the past papers to work with, and the more recent past papers, we can work with those. Because a lot of the questions in the handout are the older past paper questions, and they tend to be structured a little bit different than they are structured these days. So let us do these at least 4 past papers. I still have four past papers on the screen: 2016, 2017, 2018, 2019. These are all the June exam papers. On Saturday, I want to do a revision on Saturday, so I might actually do some more that day. All right, so let me just come off camera and so we can start. So just to practice. And the important thing is that you go and you redo the question. It's very important that you redo the same question that I'm doing. Do those first and then you try the others. All right. All right, so let's go. All right. All right, guys. So this is the 2016 question, June 2016. And the exam paper, and it's question 7. All right, so I think it's always question 7 on the old syllabus. Okay, same question 7. New question 6 on the new syllabus, 6 or 7, somewhere there. All right. All right. So this question says, it says 20 bags of sugar are weighed. Their weight, the nearest kilogram, are as follows. So these are the weights, the nearest kilogram. And since it is weighed, they're giving it to the nearest kilogram. But remember, so for example, if something weighs 12.4 kilograms, then that would basically go as 12 kilograms. All right. So basically, that's what we have to bear in mind, because it is measurement data. They are weighed. So it's measurement data. And measurement data is continuous data. So even though these are all whole numbers, it's because they are giving it to the nearest whole number. Right? But just know if something measures, for example, let's give another example, 24.5 kilograms, then that will be recorded down here as 26 kilograms. All right. All right, so let's go. So I want us to complete the frequency table, right, for the information, and we want us to do a tally. So we want to tally the scores. So basically counting off the scores. Everybody know the tally marks. That is a tally for 1, that's a tally for 2, that's a tally for 3, that's a tally for 4, and you cross it for the tally for 5. And you start again. That will be 6, 7, 8, 9, cross it for 10. All right, so each stroke you make a 1 tally, but you cross for the 5, and then you can count by 5s. All right, so we want the values between 1 and 10 kilograms. So we can do it in a systematic way. Either going to read the values across the row, read the values across here, or you can read the values column by column. All right, and you're looking for the values that are between 1 and 10, inclusive of the 1 and the 10. So let's say you're reading column by column, and you want to mark off what you have, mark off what you have used, or just underline what you have used, something like that. So we have 3, which is a value between 1 and 10, and then nothing else, right? Then here we have 8, a value between 1 and 10, and you mark that tally mark for that. In this column, there's none. In this one, there's none. In this one, there's a 5. And put a mark for that. So the tally marking for this one is 3 bags. So far, so good? But understand that so far?
Yes, sir.
All right, then we're looking for values between 11 and 20. All right, so this is 1, 12 is 1, the 11 is 1, but then the 50 is not, you don't count the 50, but if you like, you can actually mark the 50 now and put it as a tally down here on the last column there, last row there. So you finish with the first column, all right? You can do it like that, and you can do it value by value and mark them. So for example, you can do the 38, and the 38 will belong here. I can do the 43, and the 43 will belong here. And I can do the 22, and the 22 would belong here. So you can do it that way as well. Mark every figure and tally it as you go. 17 will be inside here. The 38 will be down here. The 23 will be right here. The 35 will be right here. And the 33 again will be right here. So that's 4. The 31 also will be right here. So I'm going to cross it now. And I have 5. 18 will be right here. Then 39 is going to be here. So you know 6 there. So 28 is going to be right here. 30 also is going to be here. 26 is going to be the same place. So you cross it again. I already did the 5. But I agree with that. Can you understand that?
Yes,
Yes,
sir.
sir.
You can do mark by mark and just tally for each one. So you can do it one, you can do one row at a time, but you can do it where that I just did, where you do each mark and just place a tally where it belongs. Maybe that's the easier way. All right, and then you fill in the values over here. Fill in the values over in the numbers column. So this is 4. This is 5. This is 6. This is 2. And you want to add up these and make sure that they add to 20, right? Those 20 bags of sugar. You want to make sure it adds to 20. So it does add to 20 because these 2 add to 10 and these 3 also add to 10. All right, so you know that that is 20. So you can risk you can be confident in what you have tallied. Total is 20. All right, so that's what we have so far. Very good. Very good with that.
Yes, sir.
Yes.
All right. Then they say no. For the class interval 21 to 30, that's this one. This class interval they're asking us about now. This class interval. The upper class boundary. Somebody tell me the upper class boundary for that class. The upper class boundary. Somebody tell me what the boundary is. The upper class boundary for that class, the 21 to 30 class. It's asking about the 21 to 30 class, which is this one. And now they're asking
So
for the
20.5.
Come again. Upper class boundary 21 to 30.
21.5.
Upper class boundary. Upper class boundary. The upper class boundary. All right. So you see, based on those answers, means that we don't understand the thing fully as yet. Now watch me now. This class, which is 21 to 30, means that this end can go all the way up to this end, can take value up to less than 30.5. Any value that is less than 30.5 is approximately 30. And this end can take any value that is greater than or equal to 20.5. So it is always 0.5 more than this, add 0.5 to get the upper boundary, and 0.5 less than this, subtract 0.5 to get the lower boundary. So the boundary is 20.5 all the way up to 30.5. Those are the two class boundaries, and this is the upper one, and this is the lower one. Understand it any better now?
Yes, sir. I thought the 20.5 would be the upper one.
No, the 20.5 is the lower one. Oh, that must be upper and this bigger than it. This one is larger than this. All right, so if this one is the upper one, we're going to call this one. If this one is upper, we're going to call this one. We're going to call this one lower. The upper must be more than the lower. You agree?
Yes, sir.
This is a lower class boundary. It's lower than this, a lower value than that one. And this is the upper class boundary. In other words, the values go from this low, this is from this low to this high. Remember, I don't include this, so you have to put the less than here. You have to put the less than. So a value in that class can be less than this, but greater than or equal to this. Because this would approximate to 21, and this, any value that is less than this, would approximate to 30, and that is the limit. These are the limits. Because if you use 30.5 itself, 30.5 would approximate to 31, which is in the next group. The 30.5 cannot go in this group, because 30.5 would fall in this group. 30.5 is approximately 31. So 30.5 cannot work in that group. So the value in this group has to be less than 30.5. That's why this is the upper boundary. This is the lower boundary of the class. Understand it any better?
Yes, sir.
All right, so the upper class boundary is one now. Tell me.
Sir, the less than 30.5.
No, you're gonna put the value. Upper class boundary is the value at the upper class boundary, which is the
30.5.
30.5, and you have to say kilograms because the unit is kilograms. In other words, the largest value, I know you might say, okay, but the 30.5 can't fit in there. I guess maybe if you tell the examiner less than 30.5, they give it a mark, but it is understood that the upper boundary, the values are always less than the upper boundary. It is known that the values that you use are always less than the upper boundary and greater than or equal to the lower boundary. See it here? The value in a class is always less than the upper boundary, the upper class boundary, but greater than or equal to the lower class boundary. It is known. That's how it is. The value in a class is always less than the upper class boundary, but greater than or equal to the lower class boundary. Because this upper class boundary becomes the lower class boundary of the next group. So the lower class boundary of the next group this value, and this value is the same. The upper class boundary of one group is the lower class boundary of the next group. So we can say upper class boundary, first group. This is the second group now. Second group. The upper class boundary of the first group is equal to the lower class boundary of the second group, or the following group, the group following it. All right, come now. What is the class width? What is the class width of the data? What is the class width of this class? Somebody tell me, what's the class width? Come on, man. If you're wrong, not wrong. If you're wrong, you want to learn from your mistakes if you're wrong. Somebody tell me, no, man. What is the class width? But so I'm now move until somebody answer. I'm not waste time in the class today.
Is there the difference between the upper boundary and lower boundary?
Which is what?
Is there 21.5?
You are telling no, tell me the final figure.
Oh,
What's the class width?
is there 10?
Class width is 10. It is the class width is what is the distance between this value and this value. That's what the class width is. how wide are the values that can fit in the class? Values in the class can fit between 20.5 and 30.5. So that class width is 10 kilograms. That's how wide values in the class can go in the class. You can also know by observing that these upper limit going up by 10. And you can also look that this lower limit going up by 10. So everything is symmetrically 10. But don't say that it is 30 minus 21. That's going to be 9. But 30 is not the upper boundary. The upper boundary is 30.5. And 21 is not the lower boundary. The lower boundary is 20.5. So the values can go between 20.5 and 30.5. That difference is 10. Right? So it is basically 30.5 minus 20.5. Well, you're supposed to look at this and know that it's 10. That's because this is going up by 10. That is 10 kilograms is the class width. 20 people do 30 minus 21 and put 9, which is wrong. All right. Next value. What is the class midpoint? How you calculate the class midpoint? How can you calculate the class midpoint quickly? Come on, taking too long. Forget them 3 marks here, man. Come on. That's midpoint. That's the midpoint, guys. The midpoint is the average of these two values, you know. The halfway mark between these two values is the midpoint. Similarly, it's the halfway mark between the 20 and the 30.5. So if you can average these instead. So by definition, it is the average of the two. It's the middle of the range between the lower boundary and the upper boundary. The middle of the range, right here, right here. What is the value right in the middle of the range? That is the midpoint.
Sir, 25.5.
25.5. The middle between this value and this value. But it also becomes the middle between these two values as well. Because the 20 would be right here. And the 30, and the 21, I mean, we're right here. And the 30 will be right here. Each of these are the same distance from the boundary. The limits are the same distance from the boundary midpoint. So you can also do the midpoint between the 21 and 30 to find it. But by definition, because it is a middle point between the boundaries, it becomes 20.5 plus 30.5 divided by 2. That's a halfway mark between two things, the average of them. The halfway mark between two values is the average of the two values. Right? So basically it becomes 25.5. Right? That becomes 25.5 kilograms. Note that if you average the two limit values, you get the same thing. 21 plus 30 over 2. You're going to get 51 over 2, same way, which is still 25.5. That's why you calculate midpoint. You average the values. You can average the two limit values, or you can average the two boundary values. But by definition, this is it. Because you want to be in the middle of the range of values between the upper limit, the upper boundary, and the lower boundary. What is the value in the middle of the range between the lower value and the upper value, upper boundary and the lower value? What's the middle of it? That's what the class midpoint value is. All right, you learn, you're still learning. This question says no, on the grid on page 19, no, there's no grid on page 9. So I'm going to bring up 2017, supposed to have a graph. Bring up 2017. So I'm going to do the graph on 2017 instead. See here, 27 of a graph. So if I'm ready for this, so we have to clean it up. So I'm going to use this as a graph, right? For this question. It says on the grid on page 19, use a scale of 2 centimeters to represent 10 kilograms on the x-axis and 1 centimeter to represent one bag on the y-axis. Draw a histogram. So I don't want a histogram this time now. A histogram. Now, histogram, remember, is like a bar chart, but the bars kiss each other. Something like that. And they kiss each other at the boundary values. So you have to remember bars of the histogram kiss each other at the boundary values. You have to remember that. The bars of a histogram, they go from boundary value to boundary value. The bars go from boundary value to boundary value. Bars go from boundary value to boundary value, and then the height of the bars is the frequency. But the bars must be placed at the boundary values of the data. So you need these boundary values. So the boundary values here, the lower boundary value here will be 0.5. Then the upper one will be 10.5. Then the lower one over here will also be 10.5. So because these and these are the same, you don't have to write those out. You really need to just write the upper boundary values now. So it will be 20.5 is the upper one for this, 30.5, 40.5, and 50.5. So the bar is going from those values. All right. So what a scale is must use? It's must use a scale of 2 centimeters to 10. So I'm going to set it up over here now on this graph. Let's do what they said on this graph. Use the blue. 2 centimeters to 10. So I'm going to let this axis be my mass is mass. My weight axis in kilograms. This is my weight in kilograms. All right, and up here now is my frequency or the number of bags, right? Frequency. This is the number of bags is the same as the frequency. All right, so for the horizontal axis, it's 2 centimeters to 10. So this is 2 centimeters to 10. This is 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. I want the 0.5 marks. That's where the bars are going. So if this is 10, all of that is 10. There are 10 small lines between here. So that means that this is 1. So the 0.5 is 0.5. This is 1, you know, 2, 3, 4, 5. So I want 0.5. 0.5 is right here. 0.5. And then 10.5 is right here. But that is 10. This would be 11. So 10.5 is right there. We'll mark that 10 better. This is 10 on this line right here. So 10.5 is right here. So what I'm going to do, I'm going to mark all my 0.5. This is the next 0.5. This is 30.5. This is 40.5. This is 50.5. That's where the bars go at the boundary values. And this is 0.5. First bar starts here. All right. Then the next one is the 1 centimeter represent 1 bag. 1 centimeter is 1 bag. So therefore, I'm going to put on the y-axis now. So this is 1 bag, 2 bags, 3 bags, 4 bags. That's the highest frequency. 6, 5 bags. Hold on a sec, guys. Winston.
4 of them, Auntie, yeah?
4 of them?
4 of them.
Oh, all right. Good, man. Thanks.
Yeah.
All right, Winston. Cool.
2 of them.
Yeah, man. Thanks.
Yeah.
All right, guys. Sorry about that. All right. So this is now 6 bags. And that was the highest frequency. I'm going to put up here. I can write frequency or I can write number of bags. I can write number of bags up here. All right. Number of bags, which is still a frequency. The number of bags. All right. So I can do that. Then I'm going to draw the graph. But let's draw the graph in purple. Let's draw the bar, the histogram in purple. So the first one had a frequency of 3. So the first bar going up to 3. Remember, I go from boundary value to boundary value. So this one come up right here to 3. So the first bar here coming up to 3. And the second bar also goes up to 3. This is the second bar. and then join them the top of them. That is 3. Then the next bar goes up to 4. Frequency is 4. So I'm going to extend this one at the 0.5 mark up to 4. Let's draw that better. Right in between those marks. And the next one, I'm going to go all the way up to 4. See it here? They use the ruler and draw it, guys. Don't draw it to the free and line. Then join this at the top. That is 4. All right, mark this 3 better. The next one goes up to 5. So I'll continue up to 5 right here. All right, and use a ruler and get 5 up to here as well. Next bar. And then join it up there. And that is your 5. The next bar now goes up to 6. So I'm gonna come, extend the next bar up to 6. Right here. And then this bar also, this boundary right there also goes up to 6. This end right here. It has to be at the 0.5 marks, guys. So you're gonna use a ruler and draw it properly, you know. Everything important. If you don't draw it at the right place, you're not gonna get the marks. It's a 0.5. Kind of wobbly for me because I don't have a ruler, right? And I'm gonna join the top. To get the up that I can use draw straight lines. It's okay. And then the last one drops down to 2. So I'm gonna come down to 2, come across down to 2 right here, and go across to the 0.5 mark, and drop it down there as well. This one is 2, this one is 6. That's your histogram right there, guys. Nice and easy there. That's the histogram right there. How that look? Understand that?
Yes,
Yes, sir.
sir.
All right, now the question done. So let me ask a question now. From this data, you have the histogram looking at over there, and I also have the data, the table and stuff. What is the modal class? What is the modal class? What's the modal class interval?
Sir, 31 to 40.
Good. Say the kilograms as well. Don't say 31 to 40. 31 to 40 kilograms. Unit is kilograms. This is a modal class, the one with the highest frequency, corresponding to the tallest bar. This is the bar with the modal
Sir.
class. Yes?
Sir, question, sir. You know if CSEC get half mark, sir? Or they don't do that?
Man, you answer something you asked about half, man. But don't finish answer the question yet.
Science.
At least wait till I finish explain this one, and then you ask about the half
That's a
mark.
Jeremy one, you know, sir.
Huh? Yes, sir?
That's a Jeremy one, sir.
I don't know if I give my half marks, and you shouldn't care about that. Because you should be aiming for every mark. Maybe it's about half mark, but that is irrelevant. You're going in the exam to get every mark. Over the mark, the paper don't matter because I'm marking everybody the same way. Think of it that way. So if they're giving half mark, everybody can get half mark. If they don't give half mark, everybody not getting half mark. So it's not like go and mark your paper one way and mark another person another way. So it don't really matter how they mark it. Your aim is to go in there and get every mark. Go in there and get every mark. Your aim, your sole purpose in doing the exam is to get every mark and don't worry about how the mark. The change of the mark and is human beings mark the paper. Right? The beauty about mathematics is that you can just get the right answer. There's a right answer that you can get. So you literally can get 100% on the exam by just getting everything right. You understand? Because once you have the right thing on the paper, they have to give you your marks. Right? So don't worry about whether they give half marks. I don't think they do, but don't worry about whether they give half mark. And maybe you're looking at this and say, okay, this question is just 1 mark. 1 mark. So you leave off a kilogram, for example. Would they take off a mark? I don't know. I'm not concerned about that. Let's do the thing the right way. All right, boss?
Yes, sir. Yes, sir.
All right. So the question I wanted to ask you, I was unknown. So I said the modal class. So we agree that this is the modal class, right? 31 to 40. Which of the bars over here represent the modal class?
Wait,
Which of the
wait,
bars
wait.
represent the modal class?
So the tallest one, sir.
This one represents the modal class. And how do I estimate the mode? All right, the mode. With the mode, all right, so this, what's the midpoint? So the modal class is this one. Would the mode be to the left of the midpoint or to the right of the midpoint of the class? Would the mode be more to the
To
left
the right.
or to the right? The mode. You are saying the mode will be more to the right of the class? The mode?
Yes, sir.
All right, it can be more to the right. Man, you don't see that the bars over on this side is higher than the bar over on this side. So the mode is more going to be closer to this side. Where the bar
Oh,
on
yes,
that
sir. Yes, sir.
yeah. Right? Because you have more of this weight over onto this side. So the mode is going to be closer to this side than it is to this side because you have so few persons weight down here. There's only 2 persons have this weight, this heavier weight. So the mode is going to be more to this side of in the modal class. How do we estimate the mode from the modal class? What do we do to estimate the mode? Now that we have the modal class here, we know that the mode is somewhere somewhere inside this modal class. One of the values down here is the mode between those 2 boundary values, between 30.5 and 40.5. What is the mode?
So you have to construct a modal diagonal.
Beautiful. That's what I call it. Right? I don't know if it names in a book, but that's what I call it, right? So you just draw the diagonals. You can bring it all the way over to this point right here. Right? And this one is all the way over to this point right here. Let's see if we can draw it. You're going to use a straight line, use a ruler. Draw a straight line from this corner down to the corner of the bar, top of the bar over there. And then draw one from this corner, because this really is up here now. This really is up here. That's where it is supposed to be on this line, 6 and the half point. So from this corner down to the top of this corner right here, that's straight line. So you go like this. A straight line there. The ruler, don't do it free like me. And let me see if I can get a straight line down here with the ruler. Wow, something like that. So you see where those 2 lines intersect shows you that the mode is more to the left. See, it's more to the left boundary. And to get that value, just read out what that value is. Read that value. So it looks like Carl says right in between here. Let's say it's right here. So come on here, read it down. I'm gonna change that to purple. Read that down. You read it down here. And you see what it is down here. All right. Remember, every line is 1, you know. So this is, if you look at it, this is 30. Look at it carefully. Let's use the blue. Remember, this is 30, 31, 32, 33. So between 32 and 33. So right there is 32.5. 32.5 kilograms becomes your mode, your estimated mode. But are good with that?
Yes, sir.
Yes, sir.
All right, beautiful. That's it. That's it. All right, suppose I wanted a frequency polygon. Let me erase this and let's do a frequency polygon instead. So let's say they wanted instead a frequency polygon. Let's say they gave us the same data, but they don't want a histogram. They say, okay, guys, draw a frequency polygon. Draw a frequency polygon instead. The first thing to know, frequency polygon would go from the midpoint that you would have to get in the midpoint. You're plotting points. You would need the midpoints. I'm using the midpoint to represent the class. So midpoint for the first class should be 5.5. And then because these values going up by 10, look, because the upper boundary values and the lower, the limit values, everything going up by 10, class which is 10. And the midpoint values also will go up by 10. So this would be 15.5, then 25.5, 35.5, and 45.5. Those will be the midpoint values, and those values will be in the top middle of the bars of the histogram. All right, and you're basically plotting for a frequency polygon, you're plotting these values against these values. So using the midpoint values to represent the classes, you're plotting points. The first point will be 5.53, 5.53. That will be in the middle of the bar that you had. So if I were to undo that and put back the histogram and show it in what color? Show it in green, right? It will be in the middle of the bar. So 5.5. This is 5. And we have 5.5. Let's look at it close up. This is 5. And this is 5.5. And then you want a frequency of 3. So that point is right there. That's where it will be. 5.5. All right. The next one will be 10.54. No, 15.54. 15.54 will be the next one. That's going to be in the middle of this bar. Right? So this is 15. 15.5 is right here. So that is 15.5. Right? And then you want a frequency of 4. So it's going to be at this point right here, which is the middle, right in the middle of the top of the bar. That's where that point would be. Next one will be 25.55. So again, it's the middle at the top of this bar. Then 5.5 is right here. The middle of the bar, top of the bar is there. That's where the point would be. Next one will be 35.56, which corresponds to the top of the middle of this bar, which is right here. Erase these diagonals. Right there. And the last one, we middle at the top of the last bar, 45.5 with 2, right there. All right. So those points will represent the points. So let me erase the histogram now. Let me erase the histogram. So it's basically like a plotting those points. So a frequency polygon is like a plotting points, midpoint against frequency. All right. Let's put them all in a different color. Let's put them all in blue. To stand out a little bit better. Let's put them all in a color that you can see. So those are your points. And then what you do, you draw straight lines between points. So like you're drawing a line graph first. So you have a straight line between these two, a straight line between these two. And so I'm like the first three is given a straight line. And that's because they were all going up by 1. That is why. They're all increasing by 1. And then you have a drop down to here. All right. That's your polygon now. That's your line graph, but you have to close it. So how you close it? This is how you close it. So this value right here, this midpoint value right here, is what is it now? 45.5. And going up by 10. So the value after this would be 55.5. The value after this will be 55.5 right here. But then no, 55.5 is not on the graph. If I were to put it on, 55.5 has a frequency of 0, and no bag measured 55.5. So that would be the point right here down on the x-axis. For that, so I'll put that point on the x-axis right here for that. And close this end like this. And over here now, it can come out negative, you know, but don't worry about the fact that it come out negative. It's a concept you want to understand. Since this is going up by 5, let me erase this midpoint thing. Since the values are going up by 5, by 10, I mean, by 10, the value before this would be that minus 10, which would be negative 5.5. That would be the value before this. And it has a frequency of 0. So negative 5.50. So if you were to say, okay, negative 5.5, maybe it would have been somewhere over here. Down in blue. And you get the frequency down to 0. And you close this end. And this will be an x-axis. That will be a frequency polygon. It will come to negative 5.5. Negative 5.5. And this will be 55.5. This will be the next value that has a frequency of 0. That will be a frequency polygon right there. That asks for a frequency polygon. All right, guys? Just doing that for practice. What is it? Huh?
Sir, can you repeat I got the negative 5.5?
Oh, I got the what?
Negative 5.5.
55.5. Yeah, because look here, look at the table. The midpoint values are all increasing by 5, by 10. That's increased by 10, increased by 10, increased by 10, increased by 10. So the next value, if there was another value, if it was a value after this, it also increased by 10 to 55.5. But that was not given in the table. And since it was not given, the frequency of that is 0. Because there were none of them that weighed this. So the frequency is 0. So it means that there's a point 55.50. Understand that now? So that's why I get this point over here. And the similar thing you do at the other end down here. Since the values are going up by 10, you have to subtract 10 from this previous value, from this last value, from this first value, I should say, to get the value before that. So you take this and subtract 10 to get this one. And that again has a frequency of 0. So I'm at the 0 there. So I just started negative, but no worries. So I'll put it negative. See there, I put on a graph. Negative 5.5. And frequency is 0 on x-axis.
That's 4.5.
Huh?
4.5.
I'm not hearing you anyway. It's on muffled. I'm not hearing at all.
Sir, wouldn't it be negative 4.5?
No, okay, I'm in negative 5.5 minus 10 is all. Negative 4.5.
Yes, sir.
All right, negative 4.5. Negative 4. You sure? Yeah, okay, I come to 0 first. It's true. I come to 0 first. Negative 4.5. So it's negative 4.5. Yeah, it will be negative 4.5. You're correct. Negative 4.5. But I wouldn't give you one where you'll get negative values, you know. So yeah, subtract 10. All right. So that is that. But go to that. But okay.
Yes, sir.
Yes, sir.
All right. Let's look at 2017 now. Let's look at 2017. 2017, 2017, I'm gonna click on 2017 one. So give me back the graph, but I need to bring up another 2017. So let me get another 2017. I'm gonna need another 2017 for the graph. So I'm gonna need another 2017. Graph is on page 21. All right. So let's do the question now. With your 2017. All right. So this question said the table below shows the speed to the nearest kilometer. See, again, it's to the nearest kilometer. So it's a measurement. They're measuring the speed, but they're giving it to the nearest kilometer of 90 vehicles that pass a checkpoint. All right. So these are the speeds: 0 to 19, down to 100 to 119. This is the frequency. I'm sure this is up to 90. We can check it. And then this is the cumulative frequency. My cumulative frequency is that you're adding up the frequency. In other words, that we have counting up the cars to see how many cars drove past less than or equal to the upper boundary values or less than the upper limit values. All right, that's what the cumulative frequency is. So, question says, I'm sure they're going to want us to complete it, but let's just continue first. Question says, for the class interval 20 to 39, that's this one, 20 to 39, for that class interval, as written in the table, complete the following sentence. The upper class limit now, what's the upper limit? Is what? What's the upper class limit?
39.5.
No, boss. There's a difference between limit and boundary. The boundary is the 0.5 business. The limits are the values as they appear in the table. So the limits are what are the values that are shown. The boundaries are the 0.5 below and above. 0.5 less than the smallest value, 0.5 greater than the largest value. That is because, let me show you why it is 0.5. Because it's like you're taking the halfway mark between this value and this value, where one ends and the other one starts. The halfway mark between 39 and 40 is 39.5. So this class can only take value between 19.5 and 39.5, but the upper limit is a 39 and the lower limit is a 20. So there's a difference between the class. They can ask for the class boundary, or they can ask for the class limit. There's a difference between them. The limit are the values as they appear. So it will be 39 kilometers per hour. Remember, you have to put the unit of measurement. Understand that? They're still learning. Still learning. Make a mistake and learn from it. Next one, what is the class width? What is the class width? You can look at it and know the class width. What is the class width? Somebody blur it out and tell me the class width. Pick and faster, man.
29.5.
20, 20, 20. Look, these values going up by 20. It's the same thing I keep doing. The lower limit going up by 20. The upper limit going up by 20. The class width is going to be 20. The data is always symmetrical. The lower limit going up by 20, the upper limit going up by 20, the class width is going to be 20. Everything difference between everything going to be 20. You then know by definition, it is the upper limit, upper boundary, which is the 39.5, minus the lower boundary of 19.5. For that group, that is what it is. The difference between this and this. That is still 20. So by definition, it is the upper boundary, 39.5, minus the lower boundary, 19.5. That equals 20 kilograms. But I could 20 kilometers per hour, sorry. 20 kilometers per hour. But I could know by just looking at these values how they're changing. And looking at the upper limit changing by the same thing. So therefore, the class width is 20. Everything is symmetrical at 20. All right? Come on, man. You don't have to do 1 million of them, I forget it now. I want to do 1 million of them to master it, but we don't have to do 1 million to get it. We do 1 million to master, but to get it and understand it to a point, then you don't need to do 1 million. You can do one. That's the same thing all of them. Different values, but the same concept, same approach, same everything, same rules, same method. Next one says 16 vehicles pass the checkpoint at no more than what? It's in the information, you know. 16 vehicles, so the vehicle, 16 vehicles there, pass the checkpoint at no more than what speed? See the kilometers per hour. No more than, how much? What's the answer you say? Somebody said something. Repeat it, no man. It's difficult for you in class, you know. Just people just wait for somebody to answer one simple question, man.
39
huh? 39.
kilometers per hour.
Yeah, the kilometers per hour is there. 39 is the upper limit. Look at the upper boundary, they give the marks still enough. But what does this mean? No more than. If something say must not be no more than, it means that it can be less than or equal to that value. That's what it means. If something must be no more than a value, no more than it means that it can be less than or equal to the value. So it means that they're asking us for the upper limit. Because remember, it's either you're doing less than or equal to the upper limit, or you're doing less than with the upper boundary. You understand? So once I say no more than means that you can be that amount or less. You can't pass it. So since you're dealing with that amount or less, it means that you're dealing with less than or equal to value. And the less than or equal to value is that upper limit value. Upper limit value. Upper limit value. Because that's all you can know from the data. You can only know how many vehicles pass less than or equal to the upper limit values. I can know how many vehicles pass less than the upper boundary values. Right? So, here, put it on for you. Wanted to get everything. So it's either less than or equal to these values. That's what these are, total. Or less than the 19.5 upper boundary values of 19.5, 39.5, 59.5, 79.5, 99.5, or 119.5. This question is asking us for no more than. No more than means that amount or less. If something must be no more than 20, something must be no more than 20, it means that it can be 20 or less. So it's a less than or equal to situations. They want to know how many vehicles at a speed. 16 vehicles were less than or equal to what speed? Were less than or equal to the upper limit speed, 39, because we know that is 16 cars, see there? 16 cars total. All of these cars, speed, were less than or equal to 39, including all of these values down here. Mark it for you. All of these values, all of these speeds down here, all of them less than or equal to 39. And it's how many cars? The 5 in the first group plus the 11 in the second group make it 16. So 16 cars had speed that were no more than 39. So it's 39 they're gonna place, right? 39 kilometers per hour. All right, that's that. Then now it says complete the table shown by inserting the missing values in the cumulative frequency column. So basically adding up the number of cars. All right. So based on the question, it looks as if we'll be working with the upper boundary values, upper limit values. I'm going to take these out. Looks like we are doing less than or equal to. This is a less than or equal to question. Less than or equal to upper limit values we're using. All right. So over here, we're writing how many cars at speeds that were less than or equal to these upper limit values. So you add 26. You add 26 to this. This becomes 16 plus 26. How much is that? 42. That's correct. Then you add the next 37 down here for the next group. So it's 42 plus 37. How much is that? 79. And then you add in the 9 more in this group. So it's 79 plus 9. That is 88. And then the 88 plus the last 2 cars, give me the 90. 90 cars. So 90 cars at speed that were less than or equal to 190 kilometers per hour. That's a completed table there, guys. Are you good? Are you okay with that?
Yes, sir. Yes, sir.
All right. Then now them say naturally when you draw the graph, next, right? It says on the grid provided, it says use a scale of 2 centimeters to represent 20 kilograms on the x-axis and 2 centimeters to represent 10 vehicles on the y-axis. Draw a cumulative frequency curve, a Ogive. They want us to draw the Ogive. All right. So let's go. Let's draw that Ogive. And it's gonna be a less than or equal to Ogive drawing based on what they're asking, based on what they have asked. So let's do it now. So it says on the x-axis, so we must use 2 centimeters to 20. Therefore, this is 20, 20, 40, 60, 80. And the speed went up to 190, so call it 120, right? So it's 20, 40, 60, 80. 20, 40, 60, 80. 100, 120. So it's 20, 40, 60, 80, 100, 120. Let's read the scale carefully. So there are 10 lines between here and here. So it means that each line is 2. 20 divided by 10 makes 2. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So you must always establish, make sure you understand the scale. Every small line is 2. All right, on the x-axis. Every small line is 2. And the x-axis is what again? The speed. So this is the horizontal axis. And it's less than or equal to we're gonna draw. Less than or equal to speed. In kilometers per hour. Then for the vertical axis now, they say 2 centimeters to 10 vehicles on the vertical axis. 2 centimeters to 10. So how many vehicles we have again? 90, right? So that's 10, 20, 2 centimeters to 10. Yeah. 10, 20, 30, 40, 50, 60, 70, 80, 90. 10, 20, 30, 40, 50, 60, 70, 80, 90. Right? So that's my scale. This is 0. And then now I'm doing my cumulative frequency curve. So remember, I'm using the upper boundary values against cumulative frequency. I'm doing upper boundary values against cumulative frequency. I'm doing a less than or equal to graph. Upper boundary values against. Let me draw this like this. I want to put in a value up here. Just now. Upper limit values I'm using against cumulative frequency. All right. I'm doing less than or equal to these values. How many cars do I have less than or equal to, meaning no more than? All right, so the first one is 19 is frequency of 5. Let's put that one. 19 is a frequency of 5. Remember now, every small line is 2. This is 10, 10, 12, 14, 16, 18, and 19 is right in between here. All right, so 19 over here. That is a frequency of 5. Right, cumulative frequency of 5. So it's right here, the point right here. Next one is 39, less than or equal to 39, 16 cars pass less than or equal to 39. 39. So this is 30, 32, 34, 36, 38, 39. So it's 0.5 over 4. The mark right here is 39. That's a frequency of 16. 15, 16 is right here. The next one is 59.5, frequency is 42. 59.5 is just in front here. Frequency is 42. We're coming up to 40 here. 42 is this line. So it's gonna be right here. All right. Next one is 79. Wow, what a coincidence. 79. 79 is right here. Going up to 79. Going up in front of this line right here up to 79. 79 is right here. Right, up to 79. 79. No, over here. 79 over here. So got a wrong place. Let's do it here. Right there. That's that then. The next one is 99 is 88. Is there? 99 is equal to 88. So less than let's say equal to 99 is 88 cars. Right? 99 is right here from the 100. This is the 100 line. And we're going up to 99. 99 is right up here. Right. The last one is 119, 90. 119 is just before the 120 right here. That going up to 90. From this line, just before this line, up to 90. Right here. Those are the points. And you draw the smooth curve. But look here now, you want to get the value that will come before this one. I always want to put in the value before they want to bring the graph down onto the x-axis. So the question is, these values, these upper limit values, They're going up by 20. So what will be the value that will come before the 19? What will be the value coming before the 19? Value?
Excuse me.
Negative 1. The value before the 90 will be negative 1. I'm going to put in negative 1 as my next upper limit. And the frequency is 0. So I want to show that on the graph as well. Negative 1, 0. So that will basically be, if I were to zoom it up, negative 1, if I extend this back, negative 1 would be like right here. Frequency is 0. That will be negative 1. Let me erase this. That point will be negative 1. Right? I put the negative 1 there. Negative 1. That's where that point is. Then you draw the smooth curve to the points. Let's do it like that. Like that. That's it, guys. And has that correct shape, that characteristic Ogive shape. See it? Like a S, like a cobra snake. The question now I'm gonna ask you guys. What, they didn't ask the question now, but I'm asking you, you tell me. What's the significance? What can be interpreted by this point being down on the x-axis? Remember, I know the graph shows how many vehicles. These are the vehicles. From the ones who are the lowest speed down here to the ones who are the highest speed at the top. Number of vehicles. And then these on the x-axis are the speed that they had. Based on the table, based on the fact that information, that the graph shows how many cars got less than or equal to these speeds down here. What does this point here mean? This point, tell me in terms of, or interpret that point for me, in terms of the speed of the cars and the number of cars or vehicles. Remember, the x-axis value is the speed, the y-axis value is the number of cars. So interpret that for me now. The other point, negative 1, 0. Negative 1 at x-axis, 0 is the y-axis value. Tell me now. By the way, up here says the number of vehicles, right? For this graph, up here is the number of vehicles. These are your vehicles, right? Number of vehicles. Can anybody interpret this point for me? How many cars are at this point on the x-axis? How many cars are there on this point? How many vehicles?
Sir, negative 1, sir.
Huh?
Negative 1, sir.
My boss. The
No, sir, I
value
was
down-
asking midpoint.
Yes, negative 1. So I'm asking you, how many cars are at that point?
Sir, 0, sir.
Good. And what is the speed at that point?
Sir, 0.
What is the speed at this point right there? Where I circle? What is the speed?
Negative 1, sir.
Negative 1 is the negative 1 there. Negative 1. Remember, the graph shows how many vehicles scored less than or equal to any speed where you see on the x-axis. So interpret that now based on the fact that the number of cars here is 0 and the speed there is negative 1. And the graph is showing how many cars or how many vehicles had a speed less than or equal to whatever speed you see down here. So tell me now, based on that point, So the speed is -1 and the number of cars there is 0. So interpret that for me in words. Or what do you say that? What can be interpreted at that point? Somebody interpret this for me. Nobody can interpret it for me.
You can repeat the question, please.
The question is, interpret this point being on the x-axis for me. What does it mean in terms of the cars and the speed of the cars? The graph, bearing in mind that the graph shows how many cars had less than or equal to any speed. That's what the graph showing. How many cars had a speed less than or equal to any value? That's what the
Sir,
graph is showing.
sir, it's saying that 0 cars had less than or equal to -1 speed, sir. -1 kilometers per hour.
Exactly. So no car had a speed that was less than or equal to -1 kilometer per hour. How could you interpret that -1? What do you think the -1 means? The -1 in terms of the speed, what do you think it means? The car what is doing if the speed is -1.
Sir, reversing, sir.
Exactly, reversing. So it can be interpreted. What they basically said, no car was reversing at a speed that was less than or equal to -1 kilometer per hour. Simple as that. No car. 0 means no. No car had no car passed. Remember the cars passing a checkpoint with that speed, right? No car. 0 means no or none. No car passed the checkpoint. No car reverse past the checkpoint. No car passed the checkpoint with a speed of -1 kilometer per hour. No, technically, people, for example, with the physics, would say if it's -1 you're using, they have to use the word velocity. Speed can negative. Speed of the direction, right? Velocity does. But that's what we're saying. And I remember it's me just introduced the question, and not a part of the question. I introduced it just for us to be able to learn how to interpret that point on the x-axis. The number of cars there is 0, and the speed there is -1. And the graph shows this, the number of cars that pass at any speed. So number of cars passing at -1 kilometer per hour is 0. So none of the cars passed at a speed of less than or equal to -1 kilometers per hour. None of the cars pass at less than that. All the cars pass at more than -1. All cars pass at more than -1. None of them pass at less than or equal to -1. That's it. All right. Anyway, let's continue. So I had to squeeze in that question. Question says no. Question says, on your graph, draw reference lines to estimate the speed at which no more than 50% of the cars, drove past the checkpoint. What is 50% of the cars? What is 50% of the cars?
Surname.
How many cars is 50% of the cars? Listen to the question again. On the graph, draw reference lines to estimate the speed. So if you want a speed, don't you say you have to read, find an answer where you want to so dumb it down and say, But they said the speed at which no more than remain, remember it means less than or equal to no more than 50% of the cars, no more than 50% of the vehicles drove past the checkpoint. Speed at which no more than 50% of the vehicles drove past the checkpoint. So the question is, what is 50% of these vehicles? How many vehicles is 50% of the vehicles?
Sir, 70?
Huh?
Sir, 70?
No, remember there were 90 vehicles in a bus. It's 70.
Oh, 90. Oh,
Sir,
Because
45.
so 50% of the vehicles is 45. So you want to know what speed no more than 95, no more than 45 the vehicle past that. Right? So you're gonna go and find 45. So you're talking about 45 cars. 50% of cars is 45. So you come on the graph and you find 45. Just mark it in green. Or in blue, no really matter. So you find 45, which is right here. That's 50% of the cars, 50%. You come across on a graph, and it's gonna tell you the speed. You read it down. Looks like right here. Looks like a perfect value. An exact value of 60. That's 60 kilometers per hour. Right? So no more than 45 cars passed at this speed, 60 kilometers per hour. No more than 45. All of them below. But in other words, less than or equal to 45 cars, which are the cars down here. All the cars down here, 45 of them. Passed at a speed that was 60 or less. On your graph, estimate the speed at which no more than 45, no more than 50%, meaning 45%, meaning 45 cars. Estimate the speed at which no more than 45 of the vehicles drove as they pass the checkpoint. What speed is that? 60. 60 kilometers per hour. What is the speed? 60. 60 kilometers, 60 kilometers per hour. That's it right there. No more than, that is the speed at no more than 50% of the cars pass that. That's it. So sometimes they try to twist up the words in the question and all of that, but it really comes down to something simple. They could have worded it a little bit simpler and a little bit more straightforward, but that's how it is sometimes. Any questions on that? They could have easily say 45 of the cars and I'm going to say 50% of the cars. We need to know that 50% of the cars is 45. It's 45. 50% of 90 is 45. Right? So that is 60 kilometers. Oh. All right, let's do another one. Let's do 2018. 2018 next. Let's look at it. Here is 2018. There you go. All right, so that's another statistics question. It's ungrouped data. It's an ungrouped data question. All right. So they give us the information in the form of a graph. Look at the scale properly. Make sure you understand what the graph is showing. Don't just start right and answer question. Make sure you interpret the graph properly. Question said, diagram below shows a frequency polygon. So give us a frequency polygon of the number of goals scored by a football team in 25 matches. So you have the number of matches, which they give us as the frequency. I have the number of goals down here, X. What it means that no goals were scored in 5 matches. It also means that 1 goal was scored in 7 matches and 2 goals and 3 goals were scored in 3 matches. 4 goals were scored in 4 matches. 5 goals were scored in 2 matches. And then drop 1 6 goal. 6 goals were scored in 1 match. And then drop a 6 goal. All right, question says complete the following table using information. So you see, no goals were scored in 5 matches. It had no goals in 5 matches. Right? And you continue. 1 goal in 7 matches. 2 goals in 3 matches. So we're gonna put 3 right here. Write that properly. And also 3 goals in 3 matches, 4 goals in 4 matches, 5 goals in how many matches? In 2 matches. 5 goals in 2 matches, and then 6 goals in 1 match. That's a completed table. Everybody good with that? Everybody okay with that?
Yes, sir.
What is the modal number of goals scored? What is the modal number of goals scored by the team?
Sir, 6.
The modal number of goals scored by the team is 6.
Yes, sir. Yes, sir. Yes, sir.
All right. Listen now. The 6 goals was scored only 1 time. Remember, I know it is a thing that happens the most.
Oh, sir, it would have been 1, sir.
1. Remember, when you want to find a mode, you find the score with the highest frequency. So look at the frequency first. Look for the highest frequency, and the score corresponding to the highest frequency is the mode. I may ask for a number of goals, you know. But the frequency that give you that number of goals, the highest frequency, one with the highest frequency give you that number of goals. So the highest frequency is 7. What happened 7 times? 1 goal was scored 7 times. So 1 goal is a mode. In other words, most of the time they score 1 goal. They only score 6 goals 1 time. So that can't be the mode. They only scored 1 goal, 6 goals 1 time, but them score 1 goal 7 times. Right? So the mode is 1 goal. You understand that?
Yes, sir.
The number of goals is 1. 1. 1 goal was scored 7 times. All right, 1 goal, 1 goal. 1 goal was scored 7 times. So to find the mode, when you have a frequency distribution table, you have to find the frequency, look at the frequency first. For the highest frequency, you want the score that corresponds to the highest frequency. The most frequently occurring observation is your mode. All right. Next part now says determine the median number of goals by a team. The median number of goals by the team. Also, we're gonna find the median. Remember, the median number of goals, there were 25 matches, and they are now in ascending order. Right? They're in ascending order in terms of the number of goals scored. So 0 goals were scored in 5 matches. So in other words, if you were to list out the goals scored by this team, if you were to list it out, you'd have put 0 5 times, 0 0 0 0 0. Then I put in the 1 7 times, 1 1 1 1 1 1 1. Then I put in the 2s, 3 2s, 2 2. Then I put in the 3s, 3 3s. No, there are 3 2s. Then I put in the 3s, 3 3s. 1 2 3. Then I put in the 4s, 4 4s. 1 2 3 4. Then I put in the 2s. No, the 5s. 5 was scored twice. 5 5. Then I put in the 6. 6 goals was scored once. So that if you were to list out the goals, and there are 25 values here, 25, because there were 25 matches. 5 matches here, 1 goal. How many? 7 matches here? 1 no, 0 goals in 5 matches, 1 goal in 7 matches, 2 goals in 3 matches, 3 goals in 3 matches, 4 goals in 4 matches, 5 goals in 2 matches, 6 goals in 1 match. So the goals are in ascending order. So how do you find the median number of goals from that data? There are 25 of them. How do you find the median? What would be the median? Which position would have the median number of goals? If there are 25, if there are 25 pieces of record there, which one would have the median number of goals?
Sir, the 13th number.
13th one. If you have 25 values, 25 in all, you divide it half and half. So you have 12 down the south, 12 down the sun, or 13th one in the middle. So the 13th value. So we know it's a 13th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 13th one is that 2 right there. So the median number of goals.
Sir, but
I'm
you
just,
say that.
hold on, I'm just showing you, or if you list it out, all the 25 values in ascending order, we can find the median. And then this will be a bottom half in terms of the number of goals scored, and this will be the top half up here. Right?
Wait, sir.
How do we do it from the table? You have to know that since there are 25 matches, right? In other words, these are your frequency. 25 is add up to. You have to know that if it's 25, we can know the position of the median. You know? Remember, I gave you the formula. You know? I gave you the formula. I said, see here, the position of Q2 is half of the n plus 1 term when the data is ungrouped. I told you when the data is ungrouped, like as it is here now, see, the data is ungrouped. This is the data, it is not grouped. Half of the n plus 1 term, the n is 25 plus 1. Half of the n plus 1 term is the median. That is the 13th term, 13th term in the data. So how can I find the 13th term in the table? By adding up the frequency going this way. I want a 13th value going this way. So see here, let's add them up. I have 5 of them here, so, and 7 of them here, so. So when I done that, I'm reaching 12 one already, you know, 12 gone already. 12, I have 5 here, so, and then put in and say I have 12. So when we reach the line here, so, I have 12 values already, 12. And I say it's the 13th one. 13th one must be one of these. 13th value is the median. So the median is at 2. The first 2, see there? Just as when I list them out, see there? First 2 is the median. That's the 13th value. So I can do it from the table as well. As well, I can list it out, but listing it out is more work. It's easier to do it from the table, but you have to remember that the position of it is half of the n plus 1 term. So I know that it is a 13th value in the table is my median. Remember, this is a count of the value. Frequency is your way of counting the value. What we did in the class, we say you could put in a cumulative frequency column to count up how many values you have. We can just add it up from here. You want the 13th value, you have 5 here, so, plus 7 more as you go from this way to this way, so you reach 12. You want 1 more, so the 13th one is in this set. And it's the first one in that set, which is a 2. 13th one is a 2. Just as I show it right here, the 13th one is the first 2 in the data. That means that the median number of goals is 2. Right? So the median number of goals is 13 value. That is 2 goals. Q2 equals 2 goals. The position of Q2 is a 13 value. When you look at the table, you see that the Q2, the median Q2, the median, which is Q2, is 2 goals. 2 goals is the median number of goals. Number of goals in the middle. Yeah, ascending because it's 25 matches. So the number of goals that is scored in the 13th match. But there's 25 matches they have. And the matches are in ascending order in terms of the number of goals scored in the table for you. Ascending order. So looking for the 13th one. So I just did this list now on the right side to show you that you can list them out. But suppose it's 50 values. You can list out 50 values. No, I don't need to list out 50 values. Remember the formula here. Half of the n plus 1 term. And the data is ungrouped. You have 25 term, you want in the middle must be the 13th one. So I divided 12 and 12. So it must be the 13th one. And you can find the 13th one by counting of the frequency. Remember, the frequency is a count of the values, number of values. So if you want to do a cumulative frequency row, put your cumulative, but you don't have to do it. You know, say you want the 13th one, you do 5 first, and 7 more that make 12. You got 12 already. So the 13th one must be in the next group. First one in the next set. But understand that? But go to that? Hello?
Yes, sir. Yes, sir.
And then they want us to calculate mean number of goals. You can add up them and divide by 25 and get the mean number of goals over on the right side of the page. Over there. These are the goals scored, you know. All of the goals for the 25 matches. You can add them up and divide by 25. But why do that? We can use a formula that says the mean is equal to the sum of fx divided by the number of goals. Remember, the fx is the frequency times the score. So we can actually do it right here, so same way, you know. And do it right here. So the first pair, f times x is 0. So that 5 times 0. We're doing an fx. If we do an fx right here, fx, which is a sum rule. Sum rule. Right? This 5 times x, 5 times 0 is 0. 7 ones. That's 7. I could just add them up here, so 2. 7 times 1. Then you have 3 2s. So you have the 3 2s, I mean, over here, so make 6. They have 3 3s. So let me have 3 3s is 9. 9. They have the 4 4s. Here we have the 4 4s right here. Then they add up to 16. 16. They have the 2 5s. There are the 2 5s. That's 10 more goals. 10. And they have the 1 6. 1 time then drop 6 top. 1 time then drop 6 top. And they add up these, they get the sum of the frequency. Sum of the values. So I can copy these down and add them up. Copy. Not rocket science, you know, guys. It's really it's not rocket science. I don't think it's rocket science. That's the sum of all the goals. Add them up. Plus, 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 plus. Add them up and then divide by the total number of goals, which is 25. 25. 25 matches. They can know the average goal of them scoring a match. So the total goals in all 25 matches divided by the number of matches. And this is a plus. That work out to add them. It work out to be 0 plus 7 plus 6 plus 9 plus 16 plus 10 and 6. That's 54 divided by 25. So 54 divided by 25. So the mean is 2.16 goals per match. Goals.
So that being the average?
Yeah. Goals per match. Divided by the number of matches, 25. So let's score a total of 54 goals. Now all 25 matches. If we divide 54 by 25, means that they are scoring 2.16 goals per match. That's how statistics is expressed. So they're scoring a little more than 2 goals per match. 2.16 goals per match. I know that they don't score 0.16, but for the purpose of statistics, that's what you would say. And the code NBA players, if people watch NBA and basketball, people talk about the averaging 35
points per game. You said that's what I was asking about it.
Yeah, and they don't score half point in a game, but it's just average. Just the total goals divided by the number of matches. That's what they do. And you give the value that they get. Just to mean that they score on average more than 2 goals per match. More than 2 goals per match on average they score. Even though you have some match where them score 0 and some match where them score 1. If you average out everything, comes out to more than 2 goals per match. That's that. All right, what time is it now? I want to do one more question. 2019 question was kind of different. I wanted to pay attention to this one, guys. And make it stick. Every time you're doing math and come upon a question that is a little bit different. All right? And it's a little bit different. What you have to do, you have to make it stick. Treat it as special. When I used to go to school, I used to call them special questions. Right? Special questions. You must always remember the special questions. So if you get one like it again, you know what to do. Because you make it stick. 2019 was a special question because I don't recall them setting one like that before. No, I like that. Set one like that before on a January paper. And it's one where they give the cumulative frequency. Right? And they set question like that in books, you know, where they give the cumulative frequency, you know. But for CSEC in exams, they usually don't give the cumulative frequency, they usually give just the frequency. So this question, they actually gave the cumulative frequency. They didn't give the frequency straight. Understand? So if you're in the exam, guys, remember this is a special question. So I want to treat with it this way if you ever get one like that. If the question gives you the cumulative frequency, I want you to insert the frequency. Insert it. Insert the frequency, because you're gonna need it. So you're gonna put in a column for the frequency right beside. And put it in front of it. Why? Because you want the data to appear or it would normally appear anyway to you. So I'm gonna put it right here. Frequency. Before I even do anything, I'm gonna put in a frequency column and work it out. So remember, how the cumulative frequency go is that you're adding up these values to get the ones over here. So to go from these values back to the frequency, we're going to have to subtract. So remember that you add, the first value is always the same, right? The first set, you know, is 24. 24. To get this value, you have to add the next set down here. So what do you add to this 24 to get that value? That's what it is. So to know it, you can do the 59 minus 24, which is 25, right? No, 35, right? That's correct?
Yes, sir.
What I give you that? This is 35. And then now to get this value, I have to add some more to this. So what do you add to 59 to reach 100 and 101? What do you add to 59 to reach 101? It says 101 minus 59, which is 42. Right, so the 59 we have so far plus the 42 is 101. And what do you add to 101 to reach 129? You're going to subtract them, right? It's 129 minus 101. So you have to add 28 more. Now what do you add? 129 to reach 150. You're going to subtract them, right? 150 minus 129. 21 more.
Sir.
And then when you add up these, it must add up to 150. You can double check it that way. Right? You can double check it. So 24 plus 35 plus 42 plus 28 plus 21, about 150. So before I even know what the information is about, I am inserting my frequency column. I know I'm going to need it. Information is clearer to me. So this is the number of whatever that has these measurements. Cool? So remember this, guys. Remember it, make it stick, please. Doing a statistics question and they give you cumulative frequency, insert the frequency column. insert the frequency column. How you get the values, just keep subtracting. This minus this, give it, well, the first one is always the same, right? To get this one is subtract. This minus this, give me this. And then this minus this, give me that. And then this minus this, give me that. And then this minus this, give me the last one. Remember, you have to keep adding up the frequency and then you check, add up these and see if it equal the total, just to make sure. So far, so good?
Yes, sir.
Good. Always insert a frequency column to give you a cumulative frequency, because the data incomplete. So you want to see the actual frequency for each data. All right. Frequency is very important. All right. Let's answer the questions now. Do that first. Question says the cumulative frequency distribution of the volume of petrol needed to fill the tank of 150 vehicles. So these are the volume of liquid, volume of petrol needed to fill the vehicles, and it gave us a cumulative frequency. So now that me insert this column, frequency column, it is telling me that 24 vehicles need between 11 and 20 liters. 35 vehicles need between 21 and 30 liters. 42 vehicles need between 31 and 40 liters. 28 vehicles need between 41 and 50 liters. 21 vehicles need between 51 and 60 liters. Now I know that. The data makes more sense to me than to just read this. All right? I can still interpret what this means, you know. Remember, these are your totals, total number of vehicles. All right, so we can answer some questions now. For the class interval 21 to 30, 21 to 30, which is this class interval we're talking about. I want us to tell them the lower class boundary. Somebody tell me now, most good on this now. What's the lower class boundary for the 21 to 30 class interval? Come on, lower boundary.
20.5.
Beautiful. And say the liters, the man. Get into the habit of saying the unit of the measurement. Everything important.
Liters.
20.5 liters. Everything important. Say the measurement. All of these values are in liters. So say it. Say it, man. Come on. All right. 20.5 liters. The class width. Most can tell me class width. Take quick and fast now. Quick and fast. Class width. What is it? What is the class width? Nobody not blurred it out yet. Is this all the questions are the same?
Sir, 10.
10. You can know the class width by looking at all these values going up. They're going up by 10. These going up by 10. So you know it says 10. But if you want to show some calculation, it is the upper boundary minus the lower boundary. So the upper boundary will be 30.5. That's the upper boundary of the class, minus the lower boundary is 20.5. See? 30.5 minus 20.5 is still 10. So you're going to write 10 liters. 10 liters is the class width. Good? But you could know it's 10 without doing any calculation, because everything going up by 10. And the midpoint values will also go up by 10 if you're showing midpoint. All right, next one. How many vehicles pass? How many vehicles were recorded in the class 31 to 40? How many? Look back at the table. How many vehicles were 31 to 40 class? 31 to 40. How many vehicles were recorded in the class 31 to 40? How many vehicles? How many vehicles were recorded in this class, 31 to 40 class? This class, how many vehicles in there were recorded to take that amount of liters? How many vehicles? Somebody blurt it out, no man. How many vehicles? This will not get me upset though. You guys getting me upset. The information is right there. Frequency is the number of vehicles. This is a cumulative Them will just want how much pass in another group here, not everybody. So it's 42 in another group here. 42 vehicles in this group. See the 42 there? But nobody knows blur it out 42. Nobody knows says 42. Who knows 42? Who knows says 42? Who knows 42? That's why I put in the frequency so we can know the quantity, the number for each set, each group. I said it at the beginning. I said 24 vehicles use this amount of gas. 35 vehicles use this amount. 42 vehicles use this amount. 28 vehicles use this amount. 21 vehicles use this amount. I don't want to know what them figures I mean. Note it. I'm explaining what them figures I mean. 24 vehicles use less than or equal to 20. That's what cumulative frequency is. The total. 59 vehicles, all of these, use less than or equal to 30, because less than or equal to 30 is all of these measurements. 59 use less than or equal to 30. 101 use less than or equal to 40. Less than or equal to 40 is all of these. So all of them vehicles here add up to 101. Oh. 129 vehicles use less than 50. Less than or equal to 50, because all of these are measurements that are less than or equal to 50. All of these vehicles add up to 129. That's what cumulative frequency is. Everybody, everything adding up as you go. How much vehicle use less than one? All the vehicle, 150 of them, all of them use less than 60, less than or equal to 60. All of them use less than or equal to 60. See them here, all of these are measurements less than or equal to 60. All of the vehicles, which add up to 150. So that's what the cumulative frequency does. It's adding up everybody. But if you want the number in that set here now, it's 42 of them in there. 42 of them use between 31 and 40, 42. So this question is 42's answer. See there? How many vehicles were recorded in the class interval 31 to 40? How many vehicles used between 31 to 40? That's why it was so important for me to put in that frequency column. It tells me the number in each group. That's what the frequency is, the number in each group. Cumulative frequency is everything as you go, adding up everything as you go. It's like you put in the data in a straight line and you're counting how many you have in the line as you go from group to group. Counting how much you have in all as you go from group to group. So it's 42 vehicles. The answer here says 42. 42 vehicles. Understand? Now we're going to watch over the video and do over the question. Don't tell you, I tell you guys, if you do what I tell you, see, if you guys ever do what I tell you, just do what I tell you. Now, no problem in this subject. Go home and redo the question and watch over the video. Watch over the video and redo the questions. You'll be so surprised how your understanding comes. If you have to do the question 3-4 times, you do it. If you are serious about understanding these things, you do what I tell you. Don't do what I tell you, you'll always be on the edge. You will always remain right on the edge, just there and can't cross over. You understand it to a point where you just can't get that, you just can't get that deep understanding that I would like you to get. Because you just can't find a way to commit yourself to doing what I tell you. I know that you don't do it. I know that you don't do it, and that's why you're struggling. Anytime you decide your mind to do what I tell you, redo the examples that I do. Do it how I tell you. If you have to do a question 3 times, 4 times until you can understand it fully and do it straight, watch over the video. Then when you come class, you answer anything I'm ask you. You'll answer anything that I ask you because your level of understanding will be such that you will be able to answer anything I ask you. All mathematical principles can only be fully understood by solving many, many questions. That is the only way to fully understand anything in maths, anything that is mathematics based, other subjects as well. Subjects we have to do calculations. The only way to fully understand them is to practice many questions, not 1 or 2 or 10 questions, as many of them as possible. And if you don't have many questions to practice, you practice the ones that you have multiple times. So if I only have 10 questions to practice, I'm going to practice them 10 times each. That is 100 practice that. If you only have 10 questions to use, I'm going to do them 10 times each. And that is 100 times my practice. You guys not committed to doing that? I'm not really serious about crushing this subject. I'm telling you what you need to do if you want to have a handle on this subject. Have a full grasp of this subject. But you guys not doing it. I know you're not doing it. My daughter not doing it. Understand? My own daughter not doing it. So what me expect? I'm telling you. If you guys do what I tell you, watch over the video. See, we'll find time to do other things when we could be doing this, doing what I tell you. I will find time to watch movie and browse the internet and chat, and we'll find time to do so many other things that we could just put an effort into doing what I tell you, which is with this subject. And the other subjects, we waste a lot of time. We give a lot of time to things that are not important. We give a lot of time to things that not want to improve us with these things. I don't understand it. Like there's too much distraction. And you just get caught up in all the distraction. Right? And for some reason, we just don't have the control to just limit ourselves. When I was in school, I had it. I don't know about you guys now, but I had it. And this is why I'm this good at math. I never banned this good at maths. I got good by the work. So what I'm telling you to do is what I did as a student many years ago. And when I did math in school, it was much more difficult than you guys doing now. And it was far more things to learn. Far more things to learn when I was a student. But guess what? When I was in school, every question in the textbook, I had to make sure I want to make sure I know to do them. And if I do a question and I have to struggle on it, nah, stop it till I get it. And sometimes I go to my bed and I sleep, and in the middle of my sleep, I jump up and wake up and the solution come to me in my sleep. I'm not talking about mathematics alone. All the subjects that I did was like that. So I got this good by the work that I put in. I never born naturally good at maths that way. I get good by practicing. Then I never just know stuff and understand stuff. I gain understanding through practicing a lot as a student. And the thing is, I can tell you in my teaching experience over the years, the very best students, my very best students over the years are the ones who decide to do what I tell them. Those are the ones. I can call them by name. The ones over the years who just say, no, I'm going to do everything, sir. So you give me a must-know sheet, them take it and them know it. So you give me an assignment, them shell it down and come back to more. Shell on the question, I give them and come back to more. Them do the question 3-4 times. If them can't get it, they send me the solutions or they come to me with the solution. And they do it 3 times, 4 times, and nah stop until them get it. And they practice as much question that they can find. And I had students in the past where if I give them 10 questions, then done the 10 question answer, so you have any more, I'm going to find more question and give them. 20 more, them done it and come back. I have students in the class where I give them one worksheet and then come back and finish the worksheet before the other students do one question. Those are the students who go on and tap the Caribbean and tap Jamaica and become top student in the exam and go on and top university and get the scholarships because them serious and them decide, say, okay, I'm going to just follow sir and do everything what sir say. And again, the success in the subject. Right? So if you decide in your mind that you want to be that way, you want to gain success in the subject, and you can take this approach to other subjects. It's not a guess and spell thing. This is tried and proven over many, many years. Tried and proven over many years. No guess and spell. No wonder if it won't work. It will work. It will work. I've seen it work for students who are mentally challenged. The same approach work for students who are mentally challenged. Come on and follow everything I tell them and them do well in them exam same way. Students who are mentally challenged, I'm telling you. Much less students who don't have no mental problem. I'm supposed to shut up this man. Supposed to shut up this. Right? Supposed to shut up this. Anyway, I'm going to continue. Hold on a second, guys. Don't move. Hold on a second. Hold on a second. All right, guys. So let's continue. So do what I tell you, and you won't have a problem in this subject, right? You need to commit yourselves to doing what I tell you. I'm telling you what has brought success. Many persons brought success for me, and has brought success for a lot of other students. Not just doing mediocre, borderline success. I mean, way above the line success. So if you're really serious about this thing, do what I tell you. All right. Next part of the question says, a vehicle is chosen at random from the 150. What is the probability that the volume of petrol needed to fill the tank is more than 50.5 liters? More than 50.5 liters. Leave your answer as a fraction. So look, let's look at it. So a vehicle is chosen at random from the 150. What's the probability that the volume of petrol needed to fill that tank is more than 50.5 liters? So we're going to decide how many vehicles that is out of the 150. Let's look at the data. Where would that be? More than 50.5 liters. Somebody can tell me?
Sir, 51 to 60.
Exactly. Because remember that this group goes up to less than 50.5. And this one starts at 40.5. So if you want more than 50.5, it has to be these. It has to be these. Well, these 21 cars. So these are the measurements, more than 50.5. And the number of vehicles there is 21. And that's why this column was so important, so you can know the number. All right? So what's the probability? What would it be?
Sir, 21 over 150.
So the probability of greater than 50.5 liters, can I write it like that? Becomes 21 over 150. You can simplify it down, but if you even leave it like that, then give it the marks. So that can be divided 2 by what? 3. Can be divided 2 by 3 and get 7 over 50. And leave it as a fraction, right? Divide the numerator by 3 and the denominator by 3 and get 7 over 50. Very good with that?
Yes, sir.
All right, question not finished. It says, Brian estimated that the median amount of petrol, estimated the median amount of petrol to be 43.5 liters. The median amount of petrol, he's estimating that it is 43.5 liters. Explain why Brian's estimate is incorrect. So you can explain why it is incorrect by finding for yourself what the median should be or where the median should be. There's only 1 mark for it, so it's not a lot of work. So how you think we can locate the median? Let's look at it. So he's saying that the median is 43.3, right? And they're saying it is incorrect. So let's look and see how we can determine if the median is about 43.3. Remember, I know they were in the 150 vehicles. And the vehicles are in ascending order from the ones down here are the ones with the low amount of petrol, the ones up here, the ones with a high amount of petrol. Right? And this column is a way of counting up the total number of vehicles as you have as you go. That's what this is, cumulative frequency. Counting up the total number of vehicles as you go from the ones who to the small amount to the ones who to the high amount of petrol. So talk to me now. To say if his estimate is correct or incorrect, you have to first now go and see what the median really should be. So tell me now, how can we find the median from this data or estimate the median from this data and know where the median should be about? Whereabouts with the whereabouts of the median? Which group should the median be in? How can we determine which group or which class the median should be in? He's saying it is 43.5. He's saying that the median is 43.5. So we say Q2 equals 43.5. Right or wrong? They're saying it is wrong. Let's say why it is wrong. So to say why it is wrong is to say what it is supposed to be, or around what it is supposed to be. I know that normally to find the Q2, you have to draw the graph. But we're not finding the actual value now. We just need to know about where it would be. So tell me, how can we know where the median would be? Somebody tell me. An idea of how we could approach it. Yes?
So half n plus 1, or we can just look at it.
All right. So remember now, when it's group data, the position of the median becomes half n. That's the first thing you have to remember. You would normally draw the cumulative frequency graph, and you would look now from the cumulative frequency column, you look for half of n. That's the position of it, and you come across and read it down. As if you draw the graph and you want to find the value. We're not drawing the graph and find the value. We still want to have an idea of where the median would be. So come again, think about it and come again. How can you get an idea of where the median would be, considering that it is 150 vehicles, and these are the vehicles in ascending order from the ones who to the low amount up to the ones who to the high amount. And you want the median amount. You want an estimate of where the median amount is. So if there are 150 vehicles in there, where would be the median amount? Well, which vehicle would have the median amount? But this is n, number of vehicles n. N is 150. N is 150. There are 150 vehicles. So n equals 150. N equals 150 vehicles. And these are the count of the vehicles from 24 all the way up to 150. And they are in ascending order with respect to the amount of fuel that they took. They're in ascending order down there. So talk to me now. The ones who took the low amount of vehicles are up here. The ones who took the higher amount of fuel, are the ones up here, up top. You want the median. Where would the median be in this set of data? Where would the median be?
So would it fall between 21 to 30 and 31 to 40?
No, don't tell me that. Tell me in terms of the number of vehicles. If you have 150 vehicles, which vehicle would approximately have the median amount?
So the 75th one?
Exactly. 75th, half n. So the position of the median in data is group. Position of Q2 would be half N. That's a 75th vehicle. 75th vehicle would approximately have the median amount. Remember, we are counting up how many vehicles you have in the cumulative frequency column as you go from the small number, the ones who took a small amount, the ones who took a higher amount of petrol. So tell me now, where would the 75th vehicle be? Come again now. So looking for the 75th vehicle. Looking for the 75th vehicle then. Where in this table would the 75th vehicle be?
Sir.
Yeah.
So can I try, sir? So the 75th data, sir.
The 75th vehicle.
Vehicle, sir. Yes.
50 vehicles. What would it be?
So would it be closer to 31 to 40?
Yeah, it would be one of these vehicles, the 75th one. You're gone 24 vehicles you're done this, so they put in 35 more. You put in 35 more, you're gone 59 vehicles. So when you finish all of the vehicles and take them amount of gas here, you done 59 vehicles there, so already. So you know, 59 vehicles took this amount of gas. 59 vehicles took less than 30. 59 vehicles took less than 30. All of this amount. 59 vehicles, all of them, the 24 plus the 35. Then the next group we take between 31 and 40 is 42 vehicles. We carry up to 101 vehicles. So it means that the 75th vehicle must be one of them 42, yeah? See that? The 75th vehicle has to be one of these 42. So the 75th vehicle is in one of them, yeah? These take this amount. So the 75th vehicle took one of these amounts. The 75th vehicle took between 31 and 40 liters. And the 75th vehicle is the one that took the median amount. So the median amount must be one of them measurements here, between 31 and 40. The median amount is somewhere there. So Q2 is somewhere here. Q2 is somewhere inside this. We're not going to calculate it exactly. We're not going to estimate it from a cumulative frequency, but we know it's somewhere in this range of values because the 75th vehicle is one of these 42. Anybody understand that?
Yes, sir.
Look here. We don't say it easy. That's 1 more feet, you know. Let me say it very easy, you know. Right? We have to understand that the cumulative frequency column is a way of counting how many vehicles you have as you go up in terms of the number, the amount of fuel taken. That's what the cumulative frequency is doing, you know. It's counting up the vehicles for you, tell you how much vehicle you have as you go up the line. So when you reach that set here, look, when you reach this, when you finish all the vehicles will take between 11 and 20, you have 24 vehicles. Then when you put in the next set of vehicles, will take between 21 and 30, which is 35 vehicles. You know, a total of 59 vehicles accounted for. 59 vehicles accounted for, which is them here, 24 plus the 35, not a good day. 59 vehicles. So that when you finish all the vehicles, will take this amount, up to this amount. You have 59 vehicles gone so far. Then the next set of vehicles will take the next high amount of gas, the next highest amount, or the next level of gas, then, which is this. Is 42 vehicles in there. So when you finish all of the vehicles, let me take this amount, you reach 101 vehicles now. So therefore, the 75th vehicle must be one of these. Okay, I go from 59 to 101. So you must pass through the 75th vehicle. So the 75th vehicle must be one of these. And all of these vehicles, all of these 42 vehicles, took an amount of gas in this range between 31 and 40 liters. And if the 75th vehicle took the median amount of gas, because it is the one in the middle of the distribution from the ones who took a low amount up to the one who took a high amount. So the 75th vehicle must be one of the ones that take this. And it is a 75th vehicle. Since it's a 150 vehicle, it is a 75th vehicle in the order from the ones who took the low amount up to the ones who took the high amount. It is a 75th vehicle that approximately took the median amount. And once you establish that one of these is a 75th vehicle, this is the amount that all the vehicles in this amount, this range took. All 42 vehicles here took this amount. So the 75th vehicle took one of these amounts. So when I'm telling you the Q2 is 43.2, you can see why it's wrong now? 43.5. You can see why 43.5 is not the right, it's not the correct median?
Yes, sir.
Because the correct median is somewhere here. This is the position of Q2. Q2 must be one of these values somewhere in that range. This not fall in that range there. You see it? That is outside that range. This amount is more in this group, but the median is inside there. So you see that? The median is not in there. The median is somewhere inside here. So that's what you have to tell the examiner. Something like,
Sir,
yeah.
the 43.5 liters would fit in that group what you circled, sir?
Yes, sir. 43 point, someone in there, sir.
Oh, okay,
The
sir.
median is there. Yeah, that are 41 to 50. So 43.5 is in somewhere in there, sir.
Yes, sir.
It? But the median in another group there. The median is a 75th vehicle. So let me show you the explain it on the exam. So that's all right, something like this. I explain one mark, you know. So I guess I can tell, well, themselves explain it, you know. I say explain, see? Explain it. So I have to say them something. So that's something like this. Position of Q2, where Q2 is the median, is half of 150, which is a 75th. That is 75. So when I said the 75th vehicle took the median amount. I'm going to say the 75th vehicle is in the, tell them the range now. I'm able to mark up the, put the markings up on paper to and leave it, you know, the markings here. Explain it and show it, to leave the markings. I'm not going to shade it up so much, but still, you understand me? But I leave the markings and show say the 75th here, so I write position of Q2 and put that one and all of that. Examiner see what I did. All right? 75th is in the 31 to 40 liters class. Is in the 31 to 40 liters class. Therefore, 43.5 liters is not the median. Okay? Because I said the position of Q2 is a 75th. Is a 75th vehicle. And the 75th vehicle took the median amount. See? 75th vehicle took the median amount. Then I say no, the 75th vehicle is in the class between 31 and 40. So 43.1 is not in this class. and therefore it is not the median. I can maybe say that 43.1 is not, 43.5 is not in that class. Let's say it. So 43.5 liters is not in the is not in the 31 to 40 liters class interval. Therefore, 43.5 liters is not the median. That's it. Good? But understand that?
Yes, sir.
Yes, sir.
Listen now, why you go and work over the question now? Don't joke. Go and work over the question. All right. Let's look at the last part now. So you see, you have to sugar on it now. 3 marks for this. So let's start the graph for us. And it's on the partially labeled grid below, construct a histogram to represent the distribution of petrol needed to fill the tank of 1 junk. So I want a histogram. Remember, the histogram go from boundary value to boundary value. You have to remember that. The bars of the histogram go from boundary value to boundary value. And notice they don't put any scale for the horizontal axis first, but they give us the frequency axis up here. Now, what messed up a lot of students in this exam when they did this paper is that they did not insert the frequency column. They did not insert the frequency column, and they tried to draw the histogram using the cumulative frequency. You can't draw a histogram with the cumulative frequency. Histogram is boundary value to boundary value, but you're going up to the frequency. It's a frequency you have to use. So that's why you also need a frequency column. So what are the boundary values? 10.5, let's put them in. 10.5, 10.5 to 20.5, and then it's going to be 20.5 over here. You don't need that, so you're just going up to 30.5 now. Next, 30.5, and then you're going all the way up to 60.5. And then these are the frequency values. Let me copy down the frequency values. Let me copy them down, these. Okay, I'm just putting the boundary value them to, you know. So I'm have the 10.5, 30.5, 40.5. Let me erase this. Oh Lord, too much. Right. The 50.5. So I'm going to be plotting the boundary. I'm going to put the 10.5 up here. So I will know, so we'll start at 10.5. So basically, I'm plotting those boundary values. Drawing the bars at those boundary values. And I'm using the frequency for the histogram. All right. Copy this. Paste it down here on the page so I can see it right in front of us. And put it right down here. All right, so that's it. Remember, the first bar starts at 10.5, 10.5 to 20.5 for the first bar, and it has this frequency. All right, so notice they don't give us the values for the x-axis for these scores. So it's going to go by 10, right? It's going to go by 10. Let's mark it and go by 10. So this is 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60. But remember, we need the 0.5s, right? We really need the 0.5s. Remember that, guys. The bars go from boundary value to boundary value, so we need the 0.5s. So let's count it off. This is 10 and this is 20, and each line is 1. So the 0.5 is right in between there. So this will be 11, 12, 13, 14, 15. What I want are the 0.5s. So this is 10.5. I always put in my marks for the 0.5s first. 20.5, Zoom it up so you can see it properly. 20.5 is right in between there. 30.5 is right in between there. 40.5 is in between there. 50.5 is in between there. And 60.5. That's where my bars are going, those marks. I always mark them first. 9.5. And then the first bar going up to 24. And the scale of graph first. So 24. And look at the vertical scale, every line is 1, right? Every line is 1. So 24 is this line right here, 24. So the first bar coming up to here. And draw it right in the middle. Use a ruler and you can do it more quickly and more accurately. Don't draw it free-handed like me. All right, but I know you get the picture. And then the next one is right here. 0.5 mark. Everything important. Mathematics is most exact science. Be precise with your work. And then going up to 24 line, right? This line is 24 line. This line right here. You don't want to mark it. 24. That line is 24 line. 24. The next one is 35. The next line going up to 35. So 35 here, this is 35. So extend this one up to 35, like so. And then over here, from 35 as well. So coming all the way down here. Use a ruler and you can just draw it quickly. Don't do it free-handed like me. Use a ruler. I don't have any ruler working with. All right. And yeah, 35 line is all the way up here. 35. The next line going up to 42. Next bar going up to 42. I need to find 42. This is 40. 42 is the second line above 40, right? So this is this line up here somehow. Second line above 40 is this line up here. So extend this again. 0.5 mark. Move there. Right up on here and going across to here. 42 that. And then come down right in between there. 40.5. You want to draw it on the lines and I have to be between them. It's between 40 and 41. Everything important. Mathematics is the most exact science. Don't be random. Be precise. That's 40.5. And I'm gonna put my 42 up here. The next value is 28. Next bar goes up, drops down to 28. That's a 25 here, so it's 3 lines above the 25 line. This is 25 line. See 25 line here. We're 3 lines above the 25 line. So I'm coming up here. 20, 21, 22, 23, 23. No, 28. Yeah. Oh, so it's 3 lines above the 25 line. So right, 25, 26, 27, 28. I'm on this line. So let's come and meet this bar. And I'm going across over to the 0.5. And then I come right down in the middle from a 0.5. Do it correctly. Be precise. Right in between there for the 0.5. Use a ruler. Don't draw it free-handed like me. I love when a ruler working. Right, so you're coming right in between here, 0.5. I need to get a ruler that I can use, and something that I can use on this device. You can draw lines. All right, that's it. I'm gonna put my 28 right there. The last one is 21. Drops down to 21. The 21 is just 1 over the 20 right here. This is the 21 line there, 21. Come across here, right in between there again, 0.5. Bam. 21. That is the histogram. Nice and easy, quick and fast. How that look? How that look, guys?
Yes, sir.
I would know to estimate the mode already. I know that this is the modal class. Said it multiple times. And if I wanted the mode would be obtained by doing the diagonal thing up there. There. See the mode is closer to this bar because this bar is taller. It's closer to this side. And then just read it down at the intersection. Yes. Looks like this will be the mode approximately. If they wanted the mode. They don't ask for it, I'm just showing it if they did. That looks like about 30, 31, 30, 34. So the mode if they wanted it would be approximately 34 liters. That will be the modal amount, 34 liters. Approximately 34 liters. And the question is done. But good. I'm gonna stop it there for today. What time is it now? So this was 6:45. Get a nice class to them. Started at 4, right? So not so bad. Started at 4. Okay. Remember, we started late. All right, guys. Okay, no, man. Let's do what I'm telling you, please. Let's do a short telling you, man. Let's do what I'm telling you, man. We're getting close to the exam now. So let's do what I tell you. Right? I said, go and read the questions. Just go and read the questions. So, man, you have these papers in the group already, you know. So it's 2016, 2017, 2018, 29. 16, 17, 18, 19. 4 papers with it. Read the questions. Watch over the video. Try and do the question by yourself. We're gonna practice some more. Notice we don't get any raw data on this one today. Most of them is group data. All right, so we're gonna practice some more. We'll be doing continuous revision anyway. So every time we do a past paper now for revision, we'll be doing the statistics question. We're not gonna be skipping over the statistics question. So we start narrowing down now. So what you'll find is that when we do past papers for practice, maybe it's like 2 or 3 questions we have to skip over. We more or less cover the majority of the topics now, you know. All right, so we get in there, but you have to start practicing and doing what I tell you. It's not too late. If you're even not fully up to scratch as yet, you still have a lot of time. You just need to start doing everything that I tell you to do, and you see getting easier and easier and easier. All right, guys, so I'm gonna end it there today. I send the video as soon as I get it. And I want you to just practice, do the questions over, send them to me, let me know that you do it. Right, Jermaine?
Yes, sir.
All right, good. And that goes for everybody as well. Do the questions and send me, let me see that you do them. Come on, we can shut this exam and shut it up wicked. Shut it up wicked, 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 wicked. Straight A profile, we say. All right, straight A profile. All right, guys, so see you all Saturday morning. If I apply Saturday morning, it should be a little bit earlier as I'm going to give some release. So maybe 9, 10 o'clock. I can work for 3 hours, 2 hours, you know, do a paper. All right, do a paper and so that's the plan. Saturday and then Sunday. Sunday's classwork on this topic. Maybe do a couple more questions and then I'll give you the classwork on Sunday. Monday we present it. We're looking to start. The next topic is rate of change. That's the next topic, rate of change. All right, guys. See you. Bye. Do what I tell you, please. Bye, everybody.
Bye, sir.
All right, bye, sir.
All right. Bye-bye. Bye-bye.